Hi, John.
Hello.
All right, you are live. If you'd like to do some introductions, and right after, I'll give some instructions on Remo.
Perfect. Well, good morning, everyone. Well, good morning, or I guess it's not afternoon anywhere, unless overseas. So appreciate everyone taking the time to join us again. This is our second game day activity, so we're really excited to be bringing a new topic to the community. Not necessarily a new topic, but a different topic. And we're going to focus on supply chain today. It's interesting. 2 years ago, we had an event also focused on supply chain, put out a white paper. I've seen, some pretty interesting things happen since then, specific activity, et cetera, moving forward. So really interested to see an update or to hear an update from folks who are working, really on the front lines of making all of this happen and bringing, the AM supply chain to life. So I wanted to just take a quick second to make a couple of notes. We've been considering a lot of things like everyone else has over the past couple of months. And we wanted to make an announcement this morning that after, quite a bit of consideration, we've decided that for the remainder of 2020, we're going to be operating in a virtual environment for the rest of the year, meaning specifically as it regards to face-to-face events. So the plan is for the rest of 2020 to meet virtually. I think we've had quite a bit of really positive feedback on this platform that we're utilizing right now. So we'll continue to utilize that. We've got 3 known events coming up that are currently scheduled. The first and next opportunity will be our next game day activity. That will be on July 23rd. There will be then a 4th game day, probably sometime in August or September. So stay tuned on that. Our TRX event that we had planned at Ohio State is going to take place still in August. That will be on August 4th and 5th. So we're still working with a lot of the same partners. The intention is to bring that same type of deep technical content to the community on August 4th and 5th. And then finally, the annual event that we hold typically or annually in Youngstown is going to take place this year on October 13th and 14th. However, it will be a virtual event. It will not be something that we're coming together in Youngstown for. So as all of the details become more concrete, we'll make them known, registration, et cetera. You'll start to see that for TRX, which is, coming up in the beginning of August here very soon. So you'll have the opportunity to get engaged there. But really encourage interaction here through the platform. We got really positive feedback the first time we did this. So if anyone has any questions about any of this or our approach or, how to get engaged, please reach out to myself or Tara Sarver, our events coordinator. Thank you.
Thank you, John. So hello, everyone. I am Andira Schroeder with Link3D, a workflow MES and QMS solution for additive manufacturing. And we're excited to be helping out with this event by providing the virtual stage and networking. So I will just go through a few of the best practices and instructions before we begin for everyone that is new to Remo. So right now we are in broadcast mode where the panel will take place in a few moments. You can utilize the chat function while the panel is going on the right side. And there's also a Q&A tab on the very right side where you can ask your questions for the panelists, and Terry will help moderate those questions. You can also upvote them if you see someone else's question that's already been asked that you're curious about as well. And then following the panel, we will be going back into networking. So I'm going to share my screen just for a moment. And here we go. So if you can see my screen, this is what the virtual networking view looks like. So there are each table you can join allows up to 6 people, and there's sort of a mini meeting room. And you can join different tables by double-clicking into an empty seat. So, and then one best practice we always advise is to make sure both your camera and your microphone are turned on. You can do that by clicking them on the bottom panel right there. And then next, there's 2 different views while you're in the virtual networking. So if you click tile view, you can see who you're talking to a little bit more closely. And then you can also click back to map if you want to move from table to table. Next is the chat function. So I can see everyone's sort of been using this so far, but there is a general chat with everyone that's in the event. You can use this to make announcements. You can use this to invite people to the table that you're at to start conversations. And you can use this just to talk to everyone that's here. There's also a table chat for each table that you're in for a little bit smaller of a conversation. And then there's also private messages with each individual that's in the event. And if you do have a really meaningful conversation that you want to make sure you save and remember, you can also export the chat, as you can see here. Next, another best practice is to update your profile. So if you click on the top right corner of your screen, you can add a profile picture. You can connect your LinkedIn. You can also add a meeting link to help connect with others as well. And one thing we do advise is in the first tab where it says full name, you can also add your position and company you work for as well. It just makes you a little bit more recognizable when people aren't in the table with you. And one last thing, if you are having any trouble connecting, make sure that you're using both your personal computer rather than a phone or a tablet, and Google Chrome browser works best. And then if you do have any trouble, you can message me on the chat function as well. So thank you, John. I'm going to bring Terry up now to start the panel. And Terry, you will have to turn on your camera and mic one more time. There we go.
Thanks, Andrea. Hey, John.
Hey.
All right. So this is a very exciting subject, how additive manufacturing addresses supply chain gaps and distributed manufacturing. And it's timely, it's important. It's just one that we're learning, it's evolving in real time in the context of additive manufacturing. I see the other panelists have joined us. Hey, Lou, Mike, and Colin. Good to have the 3 of you.
Thanks.
Thank you. Yeah, and so this remote platform that Andrea has talked about, it's new to a lot of us. So this is only my second opportunity, but it's very powerful in the sense that I think it's the next best thing to being in person. It's allows us to network and to do what we're doing now. So, and also you can ask questions, and then we'll do our very best to get to most of them, time allowing. And so I'd like to start off by giving each of our panelists a few minutes each to introduce themselves. So if you'd each say a few minutes about yourselves, I guess we can go in alphabetical order by first name. So Colin, if you'd like to start, please.
All right, Terry, you got it. So yeah, I'm Colin Hilkeny, CEO of 3 Diligent. We are an Industry 4.0 software and services company. So we have 2 primary products, Prodex, Product Express, which is a procurement portal, and ShopSite, which is a shop management solution. And basically, those 2 marry up on our platform. So companies seeking to procure digitally manufactured parts, in particular for our discussion today, 3D printed parts, can submit requests through our portal, and then we're dynamically matching those requests to qualified suppliers around the planet. Our network stretches across 6 continents, and we've got some fantastic manufacturers with a wide range of additive solutions.
Thanks, Colin. And you're the founder of the company?
That is true.
And CEO?
Yes, I am. Still hanging around here, Terry.
Okay.
Found it and hung around as CEO too.
And in California, correct?
That's correct. We're based out in El Segundo out west, but again, our network is global.
Yeah. All right. Thank you.
Absolutely. Thank you.
Lou?
Hi, everybody. I'm Lou Rossi. I'm a co-founder and the CEO of Fast Radius. We're a manufacturing technology company. We work with companies who are trying to bring new products to life across the process, from discovering new businesses, new applications, through the design, development, testing, validation, and ultimately manufacturing parts for them and fulfilling them where they need them around the world. We have a network of our internal factories, as well as a network of supply partners that we work with. We're focused on industrial grade additive manufacturing. Our factory in Chicago was deemed by the World Economic Forum to be one of the 9 most advanced factories in the world, implementing Industry 4.0 at real scale. Again, with a focus on industrial applications, taking additive out of the era of prototyping and into real applications to support needs of the world. We're working with customers across industries, aerospace, automotive, consumer products, medical devices, to help them bring new innovations to the industry. And it's good to be with you guys today.
Yeah, thanks, Lou. So one of the top 10 companies in Industry 4.0, according to the World Economic Forum, is that right?
Yeah, we were humbled by that recognition about 18 months or so ago. They've evaluated thousands of companies around the world, looking for companies that are embracing Industry 4.0 at real scale and how they're serving customers. And at the time, we were the only one in North America that was recognized. Since then, the Lighthouse network has expanded a bit, and the community is growing. I think it speaks for all of us about the attention around the world that is really coming into investing in Industry 4.0 technologies at scale, and we're excited about the community.
I didn't know that until today. Congratulations. That's great.
It is cool.
Yeah, very cool. Mike?
Hi, thanks for having me. It's Mike Shannon. So I work for Hewlett Packard. Been with Hewlett Packard about 28 years. All of that primarily in supply chain or in associated organizations supporting supply chain. I started my career out in injection molding, which is really my education and background. About 3 years ago, 3.5 years ago now, moved over into our multi-jet fusion organization, helping to set up our supply chain. And so I've had the great fortune to be able to work with some of our customers like Lou, who are our customers that we converted over to suppliers, which is kind of an interesting twist. And we've just really had a good time for the last several years as our production equipment, our multi-jet fusion production equipment has hit the market, and kind of find a sweet spot both within HP, which is the area that I've been working on, developing the applications, as well, of course, in the market as we're seeing it grow.
Great, thanks, Mike. So most of your career in injection molding, so you'll be able to give us some perspective on how additive manufacturing will or will not impact that particular industry. So maybe we can talk about that at some point today.
Good.
Yeah, good. Well, the current pandemic has exposed some serious gaps and holes in the traditional supply chains, and the AM industry really has stepped up to patch some of those holes to some degree, and the response really has been tremendous. It really is incredible when watching what companies such as yours, all 3 of our panelist companies have stepped up. A lot of their partners, I think HP announced 2.3 million parts produced by yourselves and your partners, and that's an incredible. A countless number of companies, organizations, schools, individuals from around the world have stepped up and done tremendous work in this area. At the same time, it's not without its challenges, of course, as we know, and so we'll try to get to some of those problems and challenges. Supply chains in general are being impacted by additive manufacturing. You consider when companies consolidate designs digitally from many parts into one and then print, it has astounding effects on the number of suppliers, or it can potentially have a big impact. For example, on a mid-frame superstructure, it's like if you can envision this cylindrical shaped housing, that GE Aviation went from 50 suppliers get this, 50 suppliers to just one using additive manufacturing. You know, imagine what impact it has on simplifying the supply chain for that particular assembly. And so that's just one example. I know your companies are doing interesting work in this area. So back to the pandemic for a moment. We'll use that. We'll probably hear quite a bit about it, but that was the focus of our first game day event. So we don't want it to be focused entirely on it, but it provides good context and a foundation for us to really probe more deeply into the supply chain and this whole idea, this notion of distributed manufacturing. So what are we currently learning from the AM industry's response to the pandemic based on your experiences? So any one of you jump in.
Sure, I can speak to that. You know, as the pandemic, hit us, I think it really caught the industry by surprise, really, about the supply chain, really, and the challenges associated with it. It's just was really a big opportunity for 3D printing to be able to jump in. And you know, when I look back at it, I think that we've been talking about all of the benefits of 3D printing, right, for years, and the pandemic was really a place where we were able to step in and prove all the things that we've been saying about design, iteration, the speed, the cost, the effectiveness. I think all of those were a real benefit to the additive industry to be able to show how it could step into some a situation like that.
Yeah, I think one of the things to build on that is that we've learned that the impact that 3D printing can have, but not 3D printing alone, but 3D printing coupled with other technologies. And so examples that come to mind are around design sharing. And Fast Radius, we were one of the many companies that developed some designs and shared those broadly in the community around the world so that others could improve on those designs, share them back, make them and learn from them. And I think what America Makes has done with NIH is an example of a design sharing and collaboration platform. And so I think one of the inspiring things here that the pandemic has shown the industry is that, yes, digital manufacturing and 3D printing, the equipment itself unlocks incredible value and the ability to rapidly produce and scale and iterate on the designs. But there's also the upfront work around digital design and collaboration that very quickly allowed exchange of ideas and information to then ultimately let the industry start making these parts. I thought for me that was one lesson, and that reinforces it's not just about the machines, but it's about the full digital thread that has to mature for the industry to really have the impact it can have on the world. And we've all had that thesis, and now it's really has come to life, the value there. And I think that plays out not just upstream in design, but also downstream in the supply chain, and that you can quickly mobilize capacity for production once that design has been locked, and you can tap into a distributed supply chain to scale. And other many examples of that with face shields is a good example where I think HP, you guys shared your design for face shield. Others have picked up on that and iterate on it. Fast Radius did the same. But then many people around the world could scale up embracing it. So I think to your question about the lessons, Terry, I think one of them is it's not just about the equipment, but it's about the digital thread that gets created to leverage the power of digital manufacturing.
Mm-hmm.
Yeah, I would just add as a final point, I don't know if we're going to jump on another question, but I think it exposed some very interesting things, both good and bad, for the 3D printing technology and industry. I mean, number one, it is extraordinarily nimble, like on the pro side, nimble and responsive. Like we talked about, people could very quickly, even if they were folks in their garage, start printing parts and respond to a pandemic in moments. And then for that matter, as Lou and Mike touched on, get designs distributed and iterated on and in the hands of folks who need them very quickly. I think the second leg of it that it also exposed, though, is that 3D printing, there are a wide scale of what 3D printers can do. If you can't corral them and direct them in the right way, they can be used ineffectively or inefficiently. I think back on some of the designs that folks were printing, they were oxygen permeable, but they were trying to print masks. And so they just had to trash a lot of 3D printed parts because they weren't intended for that application or graded to handle that. And then lastly, I would say 3D printing can't print it all. You think about the face shields as an example. Great, you're printing the band, but you're not printing the shield itself. The economics don't make sense. The limitations around clear printed materials, to some extent from a cost standpoint, shown through. So it kind of, I think, was a great litmus test to let the world know how far 3D printing has come to really provide a solution, particularly in a quick response situation, but then also that there's more ground that 3D printing has to cover from a reliability of material science and a full product standpoint.
If I could add on to that real quickly, Colin, I think that made me think about, the speed at which we moved, or our customers moved to be able to develop, say, the face shield. Literally 7 days from idea to production. And as a supply chain person, it's really important to be able to make sure that the whole landscape can keep up with the speed at which 3D printing can move. So your idea about, or the comment about the clear face shield, very important that that industry or that source of supply can keep up with the speed at which we're iterating on the 3D frame to be able to bring that together. Getting into production, now you have to be able to place orders. You have to have ERP systems set up. You have to have a way to be able to pay and to buy all the solutions. But if you've moved at lightning speed in 7 days to be able to go into production, you need to be thinking about all those aspects and ways to be able to onboard various solutions, whether suppliers or processes, to be able to be ready when you go to production.
Yeah, I think it ties into something, Mike, we've talked a good bit about for distributed manufacturing, and we're all excited and advocates of that thesis. But it's not just a matter of plugging the machine into the wall, pushing print, and everyone's going to get the same part all around the world. While that's our vision and aspiration long term, there still is a need for a quality system in a factory to ensure the parts that you're making, Colin, to your point, are meeting the specification, that it's a responsible design and a responsible manufacturing operations that adhering to the quality standards. And I think that's another important lesson here is how do we ensure the reliability and repeatability of production. For things like halo fabrication, the risk is pretty low. If the color's off a little bit or there's a little bit of texture, it's okay, it still can function. As we start getting into more sensitive products, like swabs as an example, and Mike, you guys are doing a lot of work in that space. We have Fast Radius or also leaning in that space. These are real medical devices that are being used on people, and they're having a quality system is essential. That is going through a PPAP process and going through the FDA certification, and that's where we think the industry can also have incredible impact. It's very different than the hyper distributed halo production. It requires another tier of capability in the supply chain. And right now, I think as an industry, there's still a lot to be done there.
I think that's spot on. And the last thing I would comment on, the vision behind 3 Diligent, the reason why we operate as the platform that we do, is we've truly felt to operate at the highest levels of industrial manufacturing, you have to have a quality management system tied out to that distributed chain, which is why, frankly, we have those 2 products and shop site, specifically with an eye to having that quality management bundled into distributed manufacturing. You couldn't be more right on that, Lou.
To build on what you're saying, John Wiskowski of American Makes said this: quality assurance still looms as a large, significant hurdle to the wider adoption of AM. Key in this regard is expected to be the industry-wide adoption of standards. How are you as companies embracing this, specifically industry standards around quality?
Well, I'll chime in to start. I mean, as I mentioned, both on the products procurement side, we have a bundle of different mechanisms for folks to build out profiles, establish if there are any particular production specs they need passed through to the production side. I would add to that also that we really embraced the work that American Makes did with FDA, NIH, and the VA in getting certified parts through. And so within our inventory system for parts and assemblies, we made sure that we pre-populated with the specific manufacturing instructions that were posted to that site, so that information could be passed through and that could be created in a reliably manufactured way.
Good. Mike?
I think we're, sorry, go ahead, Mike.
No, go ahead, Lou. Yeah.
I think the emphasis on quality as a gating factor for scale, Terry, is spot on. That really resonates, and we're very supportive of the work that's going on in standards. But I think we're, as a manufacturing company, we're also building a quality system that has a digital thread at every step in the process, from the batch resin that comes in, through the machine, through the temperature and humidity in the room, through every possible variable. There are hundreds of variables that go into before the machine, during production, and after the machine, that ensure we can make a part that's going to go and be usable on a car or in a medical device. And that speaks to an industrial grade quality system in a factory that complements the work that's being done in standard setting, and that's great. That needs to continue. But I think there also needs to be investment in the actual production operation, and our friends over at HP are doing great work around the machine to build that. But I think there's a lot more to be done there. And I think over the last couple of years, made great progress, but much more to still be made. And that's why at Fast Radius, we're investing in that quality system in a way that gives our customers confidence that the part we make today will be the same as the part that we make 5 years, 10 years from now.
Yeah, if I could just continue on with that, Lou. Standards, that's fantastic. But what we're talking about is the full ecosystem, right? So you can have standards, but if you don't have manufacturing processes and systems in place, then the standards aren't going to really do you any good. And if I go back to, we have hundreds of parts, literally hundreds of parts that go into our two machines, our production 5200 and then our 580 color proto machine. And where it starts for us is in the design phases, the very beginning of the process. When you're starting to be able to create the design, it's really important that you're thinking about the quality, the capabilities of the technology, and making sure that that matches the design intent. Because you could, if you, as I say, put a square peg in a round hole and you force a technology into the say it's supposed to be injection mold, and you force it into 3D printing, you're going to have fits in production trying to be able to maintain the quality of that part, regardless of how good the standards are and how good the quality process and systems are on the manufacturing floor. So you have to be able to take a look at it from the very beginning of the process when you design it, making sure that you understand the capabilities of the processes, the suppliers, the measuring capabilities of the machines, so that you're matching the right expectations of the design to the capabilities of the technology.
Yeah, I think that teases out something, Terry, I'm sure you're going here in a second, but I have to say it now in case you're not, that the design piece is so important. The economics, like one thing that maybe not everybody realized is that the progression in terms of where these parts have been manufactured, like things, the halos we were talking about for face shields, initially 3D printing them made sense because it was very responsive. But as tooling could scale up for injection molding, that made more sense for the manufacturing of that part. It can continue to make sense to 3D print things if the design is right. But if you're trying to force feed something that can be injection molded and you have significant scale, you're going to injection mold it. So the design piece of things matters not only for the ongoing economics of 3D printing, but also the performance and the repeatability. And that, I think, is what Mike teed out really, really nicely.
This is from Pradeep, another quality question. Quality seems to be important, as you mentioned, but as we build complex freeform parts, do we need to also consider design for quality measurement in conjunction with DFAM, which is designed for additive manufacturing? So how do we measure these parts?
So that's a really good question. That was a challenge that we were faced with on our 580 color printer. And the way we addressed it is because now you have these crazy geometric shapes, right? And requiring laser equipment and coordinate measuring machines, and that's fine. And you can measure it that way, but it's not really friendly in production if you want to be able to maintain it. So one of the things that we did is that we designed in little flags, little features to square up a round surface or a curved surface so that you can easily put a pair of calipers onto them. And that opened up a tremendous amount of possibilities to be able to ensure quality in production, so you were able to maintain them.
Good.
Yeah, I think this is a great example, and Mike, there's a number of parts that we've worked with where it's been a big part of the design process is making sure you can validate it. So I think it's a terrific question. I also think that as we reflect on Industry 4.0 broadly, it speaks to the opportunity for additional innovation in metrology equipment and measurement equipment. And there's been a lot of advances in optical scanning and image recognition and things that can bolster confidence and the repeatability of production. And I think that's why, as we reflect on digital manufacturing as an industry, as important as the production machines are, we also have to remember that we've got to invest along that ecosystem. And there's been terrific advances and many more coming in metrology equipment and measurement capability that can complement the things we can do, in the design and the machine.
Mm-hmm.
From Sarah, how much is ISO 9000 and ISO 13485, which is for medical devices? How much are they implemented in the AM industry?
I think I'm in an interesting position to manage that question, just given the breadth of our network. And what I would say is that not extraordinarily so. I think that from an additive standpoint, you've got a collection of shops that have sprung up that were passionate about 3D printing, and some of them have not gone the whole path down towards certification. Certain operations like Lou's at Fast Radius, you've got some certs, obviously, and so depending on the nature of the outfit, that has driven some of the certification adoption. And then you've obviously got a lot of existing operations that are now adopting 3D printing and kind of backing their way into more folks having certifications. But I would say, as a broad-based community, I wouldn't even say, probably significantly less than half of those companies that are running 3D printers, and probably way, way less than that if you consider even the independent operators of 3D printers, have those certifications. And it's an opportunity for companies, frankly, to differentiate as we push forward. But they are out there.
Mm. So we've talked about quality, processes. Cost really is a factor in terms of how AM can impact supply chains and fill these gaping holes that we saw in recent months. How do you deal with bottlenecks after the 3D printing process to lower the cost per part? And Dennis cites an example, identifying a high mix volume of 3D printed parts and sorting. So for example, suppose you have 200 parts in a batch that are in presumably a powder bed system, but I suppose it wouldn't have to be, but each part or many parts are different. How do you deal with that? It's one thing to to nest them and print them all at once, and there is economy of scale, as we know, with some of these systems. How do you deal with these wide mixes of parts and then dealing with them after they are built?
Okay, maybe just start off here. It's a good point, and it's a challenge, right? And so we do a lot with cages to be able to take small parts and print them inside of a cage. We've also done things where we have medium-sized parts where we actually connect them with, say, a runner system, like you would see maybe in injection molding, but not that robust. It's just something to be able to help move them through the process, through the different stages of the workflows. But there's basically tricks of the trade to be able to use, to be able to track and to pull them out of the build units.
I think the other thing I would add there is you can still create standard work, so that it might be a small number that you need to make today, but let's say next month you want to make some more, and the following month you want to make some more. You want to make sure that you're orienting them in a build tray, or you're putting them in the same position in a build box, and you're reducing all of the forms of variability for those parts. Now, look, if it's a prototype and some variation and the end product isn't going to matter, then that's okay. But if we're talking about high, complex, low volume production parts that are used for real applications, you still can create standards and follow those standards each step in the process, even in low volumes. And in a digital world, we have digital workflow that allows us to do that now, which again, I think for us just speaks to the excitement about the industry that's growing around the great innovations in the machines that allow us to make sure those standards are followed every step of the way.
I'll add one last thing, Terry. We talked about high mix. There's continuing innovation in this space. The name of the company is escaping me right now, but I know at Formnext last year I saw a company that had basically a scanning tool where parts kind of flow through a particular a little box of sorts on a conveyor belt, and then a scan was done and some AI was used to quickly identify which part was which, and so that part of the flow could be addressed more efficiently. I wish I could go ahead and mention the name off the top of my head. I'm sorry, it's escaping me, but I think the broad point is that there is innovation taking place in this space to help manage this high mix problem / opportunity that exists in the 3D printing world. Maybe it occurs to you, Terry.
Yeah. So what will be the ongoing sweet spots for 3D printing in the supply chain? By the way, when we say 3D printing and additive manufacturing, they mean the same thing. We really use them interchangeably, the two terms. So what will be the sweet spots for 3D printing in the supply chain in the future? Where does it offer the most value?
It's a good question. I think a lot of people have, different viewpoints. As a supply chain person, I see huge value in the front end. We call bridging solutions, right? And if you think of the product life cycle, the tails of the bell-shaped curve, if you will, development phases, it's just ideal because you can iterate, as we've talked about, design change after design change very, very rapidly and very inexpensively, as compared to injection molding, having to be able to chisel out those changes, if you will, in steel. And you say you want to obsolete a part as you're unsure of the design at the very beginning. When you don't have a $20,000 tool to obsolete, it's a lot easier to be able to throw away, a bunch of electrons. And then if you take a look at the back end of the life cycle, that's the opportunity, is to be able to, at end of life, after you've, we'll continue through the life cycle. So if you start off in development and you bridge, that's a term used to be able to get you into injection molding because of economics. And as you go through that peak life cycle in production, you come back down the end of life, as the volumes start dropping down, 3D steps back in again. And it's kind of this hybrid model where you can jump back and forth to be able to support out the injection molding. And when you're in that end of life, in our business and injection molding at HP, we have hundreds of thousands of steel tools that sit on and in specially prepared rims to be able to protect them from floods and earthquakes and fire. And then we have asset tracking on all of those. They all say property of HP, and they're coded. And there's a lot of resources that go into being able to make sure you know where those assets are around the world, so that they can print the last 50 parts for end of life. So wouldn't it be nice if you could then use 3D printing to be able to have more of a virtual, digital, warehouse towards end of life? And that can work if you start in the very beginning of the life cycle with that endpoint in mind, so that when you transition into injection molding, you have and maintain the tolerances and the mechanical properties of the 3D product, so that it can do that again towards the back of life when we're at end of life.
Yeah, I think that you hit on most of the curve. I mean, if you think about the production curve for any product, obviously in the prototyping phase, 3D printing's or additive 3D printing is going to continue to play a role. I tend to think of additive manufacturing as when you're doing production scale. That's kind of mentally what I associate with it. But like you said, Terry, it's synonymous. So obviously the production or prototyping phase, the aftermarket phase for on-demand parts, when the volumes have dropped down, continue to exist. Tooling and fixtures, can't forget those. Those are going to as an ongoing need, the ability to rapidly customize. 3D printing will always have a place there. The last place is obviously production. That's been the holy grail. And I think the important thing to understand about additive is the economics of it are improving every year. Especially in the metal space, we talk about some of the binder jetting technologies that have been brought online, some of the wire fed technologies that have been brought online. In the metals world, that is driving costs down, and we're seeing in the polymer space, HP coming into market helped have a positive impact on driving more competition and better pricing for production scale. But again, typically, if you can make it another way, you're going to make it another way. The example is when you can't make it another way. And in certain examples, there are design concepts, and the GE Leapgen engine nozzle tip has been reused ad nauseum, but there are many others like that. You think about massively bespoke products like the acetabular hip cups and other applications like that, where you can only make it with 3D printing. You get a genuine improvement in quality and performance because of that. And that's where 3D printing will also have a place in those sorts of parts at a production level.
I think that ties back, Terry, to your earlier comment about part consolidation as another example of making the unmakeable, which is doing things that you couldn't do with traditional technologies. And I think we are seeing examples where companies are embracing these in the millions of units, and Carbon and Adidas and their collaboration is well known, and those are high volume in the millions of units. We at Fast Radius announced a collaboration with Ford and Additive, where we're making high volume electrical connectors that are going out into the cars. And so this is now possible. Economics are making sense for these type of volume applications, but it does have to be coupled with a quality system that companies can rely on to make sure the parts we make today are going to be the same as we are there 10 years from now. I would also, picking back up, Mike, on your comment on the virtual warehouse, we're proud of the collaboration that we've had recently announced with Airbus and Satair to create a virtual warehouse for aerospace tools. And we work with our friends at HP on a number of these parts. And we've gone through, Mike, as you commented, upfront a design exercise to say, all right, let's design these tools with an eye on how they can be made and stored digitally. Now, they also embrace, in some of the parts, traditional technologies like machining and molding as well. So it's a system that comes together, but all of that can be done in an on-demand way. So now at Fast Radius, we have thousands and thousands of parts in our virtual warehouse. Mm-hmm. And as we reflect on the pandemic, and these are certified, PPAP approved, customers can count on them being reliably made the same way now or 10 years from now. Unfortunately, as we looked at the pandemic, in that virtual warehouse, we didn't have ventilators, we didn't have swabs, we didn't have many of the components that were in critical need. But fortunately, now we do. And as an industry, if we look forward over the course of the next decade, imagine what this virtual inventory is going to have in it to serve future challenges that the world confronts, whether that be from a health pandemic or natural disasters or new opportunities that are ahead of us. And I think that's what, for us, gets us so excited about the need to continue building this industry so that we can serve the needs of the world and our communities better.
Yeah, that's great points. And one last thing, Terry, I'd love to add, if I may. I didn't mean to pigeonhole too much the production case for 3D printing to just parts that can only be made by 3D printing, because there's a very important secondary scenario that we see commonly, and that is flexibility. When companies are looking at production volumes, but they're not entirely sure, like I was saying, with that band, if you know that design is locked, injection molded, if you know the demand is there, but with a bunch of people flooding into the market, a lot of companies say, well, I don't know if I want to tool up for that. Instead, I can continue to manage my batch orders, I manage my material loads, I manage a lot of things, and I de-risk my production application by sticking with 3D printing. And maybe I give up a little bit on a per unit basis, but I don't have those big upfront fixed costs. And I think as companies and their supply chains become more nimble, we'll see more of this, where companies say, yeah, we iterate faster through product revs, and we use 3D printing as our go-to production, even though we could make it another way.
You know, it also makes me think about the flexibility. Oh, I'm sorry, Terry.
Go ahead, Mike.
No, I was just going to say, you talked about flexibility, Colin, and that made me think just while we're in production, right? If you compare it to injection molding, to be able to, if you have a problem with a particular supplier or a particular tool, right? That machine goes down, that tool goes down, it's a very unique fixed piece of asset. And with 3D printing, when you talk about flexibility, I can now just pick up the phone and say, hey, Lou, can you guys start printing this part for me? And they can do that tomorrow. If they've got an open machine, they do it immediately. There's no transfer of a piece of steel, right? So that opens up the possibilities from a supply chain perspective, opens up the possibilities to be able to respond to national crises, right? Where you've got this flexible capital that you're able to turn on and redirect from making automotive parts to PPE literally as soon as the machine opens up, versus having to be able to, have that fixed asset wrapped up, or your capital wrapped up in that fixed asset of an injection molding machine or tool.
Yeah.
Agreed. Lou, I was going to ask you about the work with Airbus, the virtual warehouse that you helped them build. Is that for maintenance and repair?
It is, Terry. It is a library of tools that have been engineered and validated to help get the planes in the air again. And so a range of tools and fixtures that are a part of the maintenance of the aircraft.
I remember Donald Godfrey talking about the work at Honeywell Aerospace and how to keep airplanes in the air, they're willing to spend a lot more on a part, and so you can justify, maybe the traditional manufacturing cost on a given part or assembly. We'll just throw out an arbitrary number of $1,000, but they're willing to spend many times that because of the cost of that aircraft sitting on the ground. And
right on.
Are you seeing the same thing with Airbus?
We are. There's a willingness to pay there because of the value that is unlocked, and you also don't have the lead time, and you don't have, as Mike said, injection molded tools sitting on a shelf, and it gives incredible flexibility. I think the other thing is that we've designed many of these parts so that you're consolidating complex assemblies into single or components that are actually built as a single unit, but they can adjust with living hinges. Or threaded components that you can build as a single component that allows you to achieve the performance that you want in an integrated tool, unlocking the benefits that additive can provide. And so I would highlight that it does take effort to engineer and design these tools, and I compliment our colleagues over at Satair and Airbus, they see the long-term impact here. Now, the library of tools that we now have, they're there forever. And as much as we can scale up and down every day, depending on what the needs are in the market. But it does require that upfront learning and investment in designing of these tools.
Yeah. So we're going to shift a little bit here. So for us, we're all passionate, and we understand and appreciate the value that additive manufacturing brings, but not everyone shares that view, not necessarily because they don't just simply share it. It's because maybe they don't know much about it. They don't understand, because they're not in a position to really have a reason to dig deeply into it. And I'm talking about our government. So how do we get legislators to understand the impact? With all due respect, I'm not saying that that's universal across the board, but I'm sure many people in government that's not what they do. They don't have a reason to really understand how this stuff works. How do we get them to understand the impact that AM can have on a future crisis? And how do we learn from this to build resilient supply chains that are agile enough to make the U.S. Globally competitive? And this is from another question from John Wilkie of America Makes.
Ooh. Two thoughts jump to mind for me. I mean, the first thing I would say is COVID did a pretty good job, frankly, of ringing some alarm bells, I think, for the government. Now, I can't speak to every player in the government. The interactions we've had with different parties in the government, there's a lot of enthusiasm in certain corners about going all in on some serious investments in a distributed supply chain and how do we respond to crises like this in the future. And there are others who say, not our thing to worry about so much, and maybe we'll let states worry about that more. I think the one thing, though, that's one point. I think there are pockets that already care very much. The second thing I would highlight, though, is that for America to be competitive in a future manufacturing world, we have to understand things are moving in the direction of an increasingly robotic, autonomous manufacturing path. And so to get an understanding on that front, that there are certain tides of change that are happening, whether people like it or not, and really there are some of the same parties who say we don't necessarily want to be embracing this at the federal level do care very much about manufacturing jobs in the United States. So I think there's like a two-tone thing you can play on either way that says, if you want jobs in manufacturing, you want America to be a leader in global manufacturing, we really have to be a leader in robotics, digital manufacturing outside of the scope of additive, but certainly in additive as well, because it truly is a game-changing technology as it develops production capability.
So I think that's a really good summary, Colin. I think, for me, it really starts with communication, right? It really means opening up those dialogue, that channel between the government and industry, making sure that they understand the benefits and taking this whole COVID experience as a model to be able to show how 3D printing can fit in to be able to solve these crises immediately, the flexible capabilities of the solution. And then beginning to dialogue with them as HP is working with the White House and talking about a national strategic stockpile and how 3D printing can fit into that solution. And Lou's talked about this as well, as the preparation of having designs already defined in that warehouse. I think we think about a stockpile. I think people think about individual parts, right, on an inventory or on a shelf in inventory. It's changing the mindset of the community, both industry and government, to be able to understand how 3D printing can fit in and then take advantage of those benefits in a time of crisis. And again, showcasing it with what's transpired over here the last few months with the COVID crisis.
So Mike, are you referring to digital inventories where you would have a capacity of machines and materials available, and maybe distributed in places across the U.S. where things could be manufactured on demand when another crisis hits?
Absolutely, yes. That's a huge benefit, and why not, right? Because we talk about the flexibility of this capital. We could be making automotive parts and aerospace parts one day, but if that crisis hits and we're organized and we have a digital warehouse and we have regulations or processes in place to be able to make it easy and understanding what it is that's needed to be able to replace the PPE. It was a big gap we had with COVID, right? We didn't know what we needed. There weren't defined expectations, and so people had to kind of figure that out. We've learned that, so if we can document that in this digital warehouse, have these assets available worldwide, not just in the U.S., then you're able to respond much more effectively than we did here. We got to take advantage of those lessons learned.
Well,
I could add to that, Mike. I think the
Sure.
digital warehouse, as we work together, we're huge advocates of that, and I think it has an important place to play. We don't know what the next crisis is going to be in our country or around the world, whether it's from natural disaster or other challenges that confront us. And so we don't know yet what's going to go in the virtual warehouse, but we can plan ahead and predict and forecast, and I think that's important work to do. I think there's also a need for how do we orchestrate demand and supply more effectively. And I think as many bright spots and proud moments in the manufacturing industry and contributing to the crisis, it candidly also for me has been very painful to see the lack of effectiveness and response in many ways. And getting products in the hands of people that need them. While we've been clamoring for the need for products for medical workers, and we've had idle supply on the other side, factories sitting idle that could be making things. So there's tremendous inefficiency in orchestrating demand and supply. That's another example, I think, of something that needs to be addressed. I think broadly, the Defense Production Act was implemented this time, and in a way, again, many great examples of value and impact there, but it was implemented as if it was a few generations ago, as opposed to a Defense Production Act that is designed for a digital age. So what I hope happens over the coming months and quarters is really a fresh look at how the full suite of Industry 4.0 technologies in a digital age can be brought to bear to mobilize government response onto this type of crisis. And I think the digital warehouse is a great example of one of those, but there's dozens of other things that with a modern mindset, we can do much better to mobilize the resources and assets in the manufacturing industry. And I think America Makes Plays has an interesting part to play here. John. So I appreciate the question, and also our friends at MXD and the National Network of Innovation Institutes. In many respects, this is a great example of how the government did get this flywheel turning to create a community of manufacturing leaders that want to answer these kinds of questions. And I'm hoping and eager to be a part of that conversation and supporting the Innovation Institutes, American Makes, MXD, and the others. It's an important conversation that needs to happen. I think we also, guys, we can't, one of the other reflections, I think we can tell the stories of good successes of the last couple of months, and that's great, but we can't stop there. We do have to paint a very clear vision of what should come next and the muscles that need to be built. Because the folks in Washington, they're not going to know. And I think it's incumbent on us as manufacturing leaders to help make that clear. Not just telling the stories of success, but painting a vision for what's possible.
That is exactly right, Lou. You hit it on the head. Thanks, because I was going to make 2 final points on that. Number one, we have to highlight what is possible with this technology, because we engage certain governmental organizations, and we've obviously got a platform that can connect demand and supply very efficiently, effectively, and address that problem that was talked about. And we found that certain government organizations said, well, we've kind of got our stuff in place, we're going to go ahead and stick with what we've got. So they weren't comfortable with the notion. They have to understand these options do exist and they work. And then the second thing, you come back to it, how do you get government to act? Votes, right? At the end of the day, if there is another pandemic like COVID, and maybe it's an exogenous shock like a disease, or maybe it's a military threat, who knows what it is. The main point is you got to communicate to those political leaders. If these solutions existed today and you had COVID to learn about it, fool me once, right? Shame on you. Fool me twice, shame on me, right? Like, this existed. And if you didn't take this opportunity and this COVID shock to say, we need to put these solutions in place, you're going to lose your spot in office, because the voters aren't going to accept that you have this opportunity to learn and you didn't take it and take actions on
it. Do we know of any steps being taken to move that forward in an organized way? Lou, Mike, Colin, John, I guess you're not.
Yeah, J-Dub, you got to jump on the camera here for a second. Be as brilliant as anybody.
There are conversations.
Yeah, there's certainly conversations going on. There's probably 3 or 4 different bills that have been introduced in the last, month or so. There's some pretty interesting language directly around, how does a, whatever you call it, but a digital kind of stockpile fit in. I mean, I think we've voiced some recommendations, I'll say, as far as what that should look like, and many have. I think many of our partners, some of the biggest, have expressed some of the very things you guys just walked through. So it is certainly active. I can't remember who, I think it was Lou who was saying it, though. We really need to think about how do we take advantage of what has been very challenging. It's a great opportunity right now, but we also forget things really quickly in this country. So how do we get this captured in a manner that is impactful? So we're working right now actually with our government relations advisory group as part of America Makes to try to figure out how do we tell that story the right way, and from a national perspective, how do we get people to understand how to keep moving this forward?
Yeah, I think you're spot on, and I think it really, as I started out to say, I think it's a lot about communication. It's really about sharing. It's helping to be able to educate. There are conversations that are happening. I know with HP, with America Makes, others that are trying to get that information up to the White House. They are soliciting for feedback, and we're providing feedback. Others need to be able to make sure that they're pushing the lessons that are learned and the opportunities, as Lou's identified as well, right? That this is what we need to be able to do it better. And those conversations are starting now. So I think that's a very positive sign.
Yeah, I think one last thing, and I'll get out of here, is we're trying to help organize some of that. So hopefully in the coming weeks and month, we'll start to put some of that story together. There's a few different folks who in agencies that seem to be pretty interested in this. So we're going to be hopefully starting to pull from many of the folks on the phone to I think we really need to figure out how do we really capture the story that took place, and how do we then relate that to the future? It's great, and it's great to think about it or it's important to think about it from a crisis point of view, but it's probably most important to think about it from an overall supply chain resiliency point of view. So we'll be reaching out here in the near term. We've got something called member mobilization that we're going to be trying to make sure we get these stories captured and then start to thread it all together from a kind of national narrative from how we reacted in the crisis, but how do we position ourselves moving forward and to make an impact.
Thanks for that, John. That is important work, John. And I think very much in the spirit of what these innovation institutes were created to do is to be able to advance the state of the industry. I would also highlight, we've talked about what's happening in our own country, but it's been inspiring as we've talked about to see how cross-border collaboration has happened just around the world. And I think we have to keep an eye on that too. There's some energy for a very nationalistic within our four walls kind of mindset here. But I think the real opportunity is to think about how a digital age can help the whole planet better confront these types of major challenges. And I think we've been a part of the World Economic Forum community, and through this process, there have been very regular interactions with companies all around the world that are sharing lessons and resources. And I'm hoping that our citizens of the world mindsets will help us really advance the human condition here, and as we build the strength of the industry response.
Mm-hmm. Yeah, I agree. There are opportunities for global solutions. When this COVID story broke, we had designers and manufacturers on 4 continents all together on a call, even before we had designs that had been locked down, to say, what can we make? Where can we be deploying our resources faster while this kind of guidance from on high comes down to us? And that is really remarkable. You couldn't do that very long ago. You can't have the conversation we're having right now with a real human interaction. You couldn't do that just a few years ago. So we have to seize those tools. And I think, again, I can't emphasize it enough, John, your work is so important here. And I think it's got to come back to, we can't have something like this happen again and not be prepared. The voters won't stand for it. Like, we had one shot at this, and you really, I think, have a great calling card, for better or worse, to put 3D printing now in more of a limelight, because it can be part of the solution. It can give responsiveness the way that no other technology can. And in the digital repositories that we can build out don't cost a whole heck of a lot. So we need to seize this opportunity and bring it back to the fact that if you want to stay in office, if something like this happens again, you need to have taken action.
Yeah, I agree with all of you. John, the work that you're doing is vital, absolutely important. And it reminded me of a visit to the Pentagon last year, and how these groups came together, each from a different branch of the military. These were experts in additive manufacturing, and how deep and wide their understanding is of the subject, and how important it is to them, and how passionate they are. And it's just like, wow, I'm proud to be an American when I step into the Pentagon and hear from these people. And some of them, John, and I'm sure they would be very helpful in partnering at some level to move this ahead, because this is so incredibly important. So let me know, or let us know, if there's anything we can do to help. We have a couple of questions here, one around security and another around talent. So we're going to talk about those. Each one received 4 votes. First, on security, this one is from, the person's name disappeared. Maybe he went or she went anonymous on this. But how do you ensure the supply chain is secure? Moving to a fully digital thread creates a number of threat vectors, which we cannot forget. How are you protecting data?
Yeah, so for us and Fast Radius, we're powered by a software platform that we have built with government secure infrastructure, similar to what's being used in the financial services industry. And so if we reflect on other industries that have gone through a digital transformation, including moving our money around, that we're all comfortable, many of us are comfortable doing on our phones now, there is a way of securing digital information. But you've got to invest in it. And I think it also speaks to some of the risks of hyper distributed production with smaller mom and pop shop all engaging and contributing. While that's suitable for a portion of the manufacturing economy, I think as we reflect on production and more sensitive types of information, you need to have, still it can be a distributed network, but it still has to have a different level of security, not just in the platform, but in the production locations themselves. And so we're investing in that a lot in our supply chain. And I know Mike and the friends at HP are doing it in the machine and the infrastructure around the machine. But I think we should also be mindful that it has happened in other industries and it is possible here, but there's work that has to be done for sure. Particularly around counterfeiting of digital designs and the like. I would also highlight, though, if we reflect on traditional manufacturing and how information is exchanged traditionally, where people might be sending an email with an attachment, or someone's carrying around a thumb drive with the instructions for the machine, not terribly secure. And so even in traditional manufacturing, there's incredible cyber threats that exist. And I think as we, at Fast Radius, we're building this next gen digital infrastructure, embracing the security that exists in the digital age that is being employed in other parts of the digital economy, bringing that into manufacturing to give our customers confidence. I don't want to say it's solved. There's work we have to do there for sure. But it's a solvable problem and we have to just keep leaning into it.
I think it's a really good question, though, right? Around security. I don't pretend to be an expert by any means, but it's an area that Hewlett-Packard does excel in, and security is a big piece of the electronics, consumer and industrial applications that we develop. I know just personally, we have a lot of internal processes, right, and procedures that we have to follow. So it's just like we don't, like Lou just mentioned, we don't email designs to anybody. We have secure protocols where we transfer files from one supplier to the next. That's embedded with security. Yeah. So I think one, it's being aware of it, and two, making sure that the technologies you're utilizing are able to be protected, right? And that you've taken the right steps to be able to invest in the right measures.
That's right. There's a lot that can be done right now. At the end of the day, though, Lou kind of teed it up. You work with certain partners, and those certain partners are able, there is still to some extent a human component. You can encrypt everything. There are some blockchain solutions that exist in market. There are ways to kind of tokenize production that exist in market. The adoption curve on them is what it is, right? Like until you've got broad-based penetration, securitizing we're not doing securities law, but securing your entire supply chain has some inherent challenges. One of the ways we address this, obviously, is since we're working with multiple partners, they're not able to download any files until they've actually won the work from us. But I think we're talking about ultimately making decisions on the suppliers that you're using and making sure they have the right infrastructure in place to handle things. And that's why we have a Products Connect option where we just tee people up directly with suppliers. They're all connected on our secure portal, which is fully encrypted. But at the end of the day, they can interact with each other because for more sensitive production applications, that's just what you need.
I think it's another illustration for the additive industry to advance. There's innovations that are required across this digital threat. And security tools is an example, and speaks to the need for us to continue investing and continue building.
And your three companies, I'm sure, you've been in this for a long time, and so you know about a lot of the threats and so forth. For smaller companies, startup companies that may be less familiar with cybersecurity issues, don't rule out contacting the local FBI. They will come on site. They will do seminars, put you on email distribution lists, and really help bring you up to speed. I mean, they have experts who know a lot more about this than many of us. So that's a resource that perhaps some of us don't tap into. The question around human resources and talent in particular. This person also did not disclose their name. How is access to AM talent impacting your organization? Is it getting better? Are we seeing formal education, schools, higher ed, the workforce in general, creating more talent? How do you see this unfolding now and in the future?
Well, we've been charmed to have more people with additive backgrounds applying or reaching out about job opportunities than we have space for. So we've been really happy about that. I do think where I see an ongoing challenge in workforce development, which is something to keep in mind, is running these machines. Like running a machine that is a 3D printing machine is a step beyond running a CNC machine, right? Because there's a metallurgical component on the metal side about laser strength and some of the atmospheric conditions and how fast your scan speed. There are so many extra variables in there that I do think that kind of more robust combination of wanting to run a machine but also having a mind for math and science and marrying those two instead of just being someone who's got a good skill set for a lathe, like that is an area where I think if we really take off the way we should in America, that's a skill set that should keep being developed. I can't speak to how big that gap is at the moment. Maybe these other gentlemen can.
So my comment here is that I think we need to do more, right? I think we need to invest more in our universities and making them aware of the need, the demand to be able to create for the future, right? But if I also look at companies like Luz, they've done a really good job of reaching out, tapping into those sources and bringing in really powerful talent. And that's what differentiates, right, the supply base for us, our customers and their offerings is really that talent. But I think we need to do more as an industry to be able to educate the universities to have curriculum around the sciences of 3D printing.
Lou?
I think it's nicely framed, Mike. We do need to do more. I think absent our ability to influence universities at a large scale, we have just invested, we're a small company, in building curriculum for all parts of our business, from our commercial team members who are engaging with customers to our project engineers to our frontline workers. And there are platforms that we're using where we're digitally capturing standard work part, and then new operators and technicians that come in can go through a structured way of learning the methods and the techniques and the standards for each part. So there are tools that can accelerate the learning, but we've had to invest in those in light of what the broader market is. And we're fortunate as we do, I think, like Colin commented, we have wonderful people that are excited to come in, and we have degreed engineers working as technicians in the company as a way of really learning what it takes to design and make these products. And I think there's opportunities at all career bands and education levels, which has been exciting too, but we've had to lean into that. And I think Mike said it really well. As an industry, we need to do more.
Yeah, I agree. I don't want my comments at all to suggest anything other than that, because anybody coming out of school too, there's just so much in the 3D printing world. I mean, there are so many technologies. There is such a brand new blank space in terms of designing for additive, and nobody comes out of school with a clear understanding of that's really out there. And so there's no question that we can and do need to do more. So yeah, I just want to make sure that I didn't imply anything incorrectly in my comments.
Terry, I'd pick up one additional thread on this. And when people think about training, they often think about the technical case. What we've also found is that the business case for additive also requires education. And we worked with a number of our customers, and as we work with our customers who are trying to embrace additive in new product development and as a business strategy, we put as much energy into building a business, helping them understand the business case for additive, and thinking about how do you mobilize an organization? How do you mobilize supplier quality to understand the nuances of additive? How do you mobilize finance to understand the economic trade-offs of, the piece price might be a little bit higher, but you realize we're we don't have the CapEx up front, and the finance guys say, well, I'm not so sure. So, I think the education is not just for us to really get the flywheel turning here. The technical stuff we talk about a lot, but how you mobilize the business and how you mobilize the organization to adopt it is equally as important. So at Fast Radius, we've created programs for our customers where we're systematically helping them build capability across all three of those dimensions: mobilizing, understand the technology, but also mobilizing to understand the business opportunities, and then mobilizing the organization to drive change. And we think that's how we get the flywheel turning in a really big way, not just on the tech side.
Yeah, in some ways, the business part can be more difficult than the technical part because it's often more black and white, whereas the business part can be a little gray. For example, suppose you're working with a customer who has this project and it does require new design work or redesign work, and you take that out to not to necessarily to an extreme, but you take it to a point where you are really impacting, say, part count and maybe weight, material, and so forth. And trying to do the numbers on that is not trivial. Absolutely not. You really almost have to take it down a path with your CAD software, maybe other tools that does require talent and technology and so forth, but you have to do the numbers to justify going down that path versus the traditional way.
Terry, the analog for me is that back in the 90s, people were talking about low-cost country sourcing. And there was it's just wage arbitrage is going to get us to a lower cost product. But when you added in the total landed cost, right, it would lead you to a different answer. And a lot of companies made mistakes as they were setting up their supply chains because they didn't take a total landed cost view. We think there's the same challenge in additive right now. So at Fast Radius, we've created something we call a total value of additive, or TVA, that is a methodology for quantifying the value of additive at every step, both top line as well as bottom line. Because to your point, Terry, it requires skill to think through this. And we've worked with our friends at HP in a number of partnership situations to help customers understand the broader case to drive adoption.
Yeah, it's a real challenge. I'll just make one last comment. We're trying to quantify risk. We're trying to quantify flexibility. A lot of these decisions we were touching on earlier, the production cases are either we can only make it with 3D printing, and you're quantifying performance. Like, how much is that performance going to be worth in the market because it's a better part, even though it might be more expensive. And the second one is we're de-risking our go-forward plan because of using 3D printing as our technology of choice. And then in those kind of scenarios, the bean counters or whatever, and as one of those bean counters, a lot of times you're trying to use discount rates and whatnot in the finance department, and that is a tough number to try and slap on some of these decisions.
I would also add, Terry, just as a point of caution for the industry, that if we don't get this right, it actually can really slow momentum. If companies are trying to design something for additive, but they don't have the right technical expertise, if they're just uploading a part and pushing print and they say, oh, that's not what I wanted, or if they just look at a piece price online and say, hey, this price is $5, why would I ever do that? That's not a business case that's going to scale. Without that insight and partnership up front on design and on the business case and the organization side, it actually can turn people off and turn people away from what really does make sense. But you just have to have the knowledge to get it. And I think it goes back to your question, Terry, about the talent, the human factor, capability building that needs to happen in the industry, technically and business, to make sure we overcome those risks. So we don't slow down, but we keep growing.
The underlying theme here is, obviously it's 3D printing we're talking about, but this is manufacturing. And as we bring manufacturing back to the United States, we also have to be able to increase our knowledge about manufacturing in our institutions, right? To be able to figure out how do you economically do this stuff and how to be able to look at the break-even points, I think is important.
Well,
Yeah.
To that point, we need the industry to continue developing more cost-effective solutions. At the end of the day, people are going to be looking. I mean, it's a dollars and cents decision, and when it's really far apart, there's no amount of flexibility that's actually going to push somebody over the edge. So I think there needs to be a continued push on that front. I had a second thought. I might throw it in later, but it just escaped me. So
I'll
Carrie,
echo
back
that
to you,
one.
baby. Okay, thanks, Lou. I like it. Good.
Mike, can you help us on that front, man? Just keep driving the cost down.
More efficiency. I would 100% agree with it, though. We have had customers where they just start out price, and you don't even get the conversation going, right? It's just the gap's too far. The gap is just too far. Oh, well, we checked it out. It's not a fit. And that information, this was my second point. We need more success stories. It can't all be the LEAP jet engine nozzle, right? It can't just be knee braces. But the problem is publicizing those success stories. Because it's manufacturing, a lot of people like to keep it close, right? And because 3D printing is not publicly established as every bit as good as injection molding, or sometimes in your metal parts, it's got better than cast properties or forged properties. Like that information still is not propagated. There's still a level of doubt. You're still selling a lot of times into engineers, which as a broad groups trend conservative on decision making. What is the real upside for them in this? So like the math's got to get better, and the success stories so that people are comfortable adopting have to become more pervasive. And that's a partially America Makes challenge, and it's certainly on campus too, where we get more of those case studies out so people know what is possible.
And kind of to allude to your point and cost, driving costs out, right? We're typically not competing against ourselves in 3D. We're competing against really inexpensive injection molding product coming out of China, right? A lot of that's subsidized. So that puts a lot of pressure on U.S. manufacturers in this industry to figure out how to be able to add the value, right? How to add value, how to be able to drive costs, how to be able to do it so it competes. And it's not always about cost, right? But to have that the functionality that helps to differentiate it from the inexpensive injection mold solution. But I'll go back to my original statement. You don't want to put a square peg in a round hole. And if it needs to be injection molded, it needs to be injection molded. And if it doesn't, then you figure out what differentiates it to be able to be in that into the technology of 3D. And then it comes back around, Terry, and Lou, to everybody's point, Colin, it comes back to talent, right? It comes back to people that have experience, that understand manufacturing, they understand supply chain, they understand the economics, and they can put creative thought process together how to drive efficiencies in their operations to be able to help them differentiate the value proposition. So to me, it's end to end from design to all the way through all the accounting principles.
So sometimes, Mike, it's not all that easy, though, and sometimes it is. I mean, if it's I don't know, production run of, let's say, 500,000 pieces, and it's a pretty good sized part, maybe the size of I don't know, an orange or an apple, or maybe even bigger, then it's obviously injection molding would be the solution. But suppose it's a much lower quantity, and then you have to enter into the equation the flexibility that you have, and manufacture on demand, mixing maybe more than one variation of a product solution, and in all those factors, then you can certainly calculate a break-even point where on one axis you have quantity, and the other you have cost, and there's a certain point where it becomes either more expensive or less expensive to use one versus the other. But then these other factors enter into it and complicate, but really help to some degree with building a business case around one versus the other.
So I think, your comment is it's not always easy, and I agree. If it was easy, we'd have a lot more people doing this.
That's right.
And I think that is really a solid point, right? And it goes back to the knowledge base of these organizations. How do Lou and Colin differentiate themselves, right? And it's through the business knowledge, it's through the experience, it's figuring out how do you take that really low volume application and streamlining your operations and your processes so you can eke out more margin out of it by combining it with other jobs, by using the flexibility of the capital we talked about, knowing the iterations that it's going to have to go through, that it's going to be more cost effective, especially in the front end as you go into design phases. And having that knowledge gives you the competitive advantage that I think that we need. And again, I think it just keeps coming back around. It comes back to and how do we embed that in our organizations?
Yeah, absolutely. Dustin asks, is America Makes going to implement any programs to increase diversity? So John, if you're still around, great to have you rejoin. Meanwhile, if we have any comments from our three panelists, you're welcome to comment as well.
So I saw that, and there's a couple other questions out there around the topic. I won't pretend to have a great answer as far as how to do that. I think we regularly try to think about that as we're building panels to make sure. I think most important to us is making sure we're getting the best cross section of industries, and diversity means a lot of things. It certainly means a lot right now. But it also means a lot beyond that. We've certainly been characterized as an institute as something pretty specific to an industry. Aerospace regularly comes up. That's certainly not the only industry we care about. Being able to bring content to the community that is relevant is really what we want to be focused on. I've been texting in the background since the question came in. How do we figure this out? So I won't pretend to have an answer right now, but we're certainly paying attention to it, and I will suggest we will make sure we're taking that into consideration as we do things moving forward.
All right. Thank you, John.
I'll just offer up, at 3 Diligent, we believe that diversity makes us stronger. So if anybody's on the call from diverse backgrounds, we hope that if there's a job opportunity at 3 Diligent that you're a fit for, that you'll reach out, because we're certainly big believers in that.
Yeah, I think that as well, Colin. I think that from HP perspective, a very large organization, diversity is kind of the center of who we are, our core. We believe that you've got to have a diverse workforce because we've got a diverse customer base, right? And so we are big supporters of women in 3D printing. We're big supporters and trying to promote within the universities talent to be able to be attracted to the sciences, right? And so again, I probably say this previously, but we got to do more, right? There's never enough, but you always have to reach out and be able to tap into that power.
I think diversity matters in all its forms, consistent with my colleagues here. And I think as an industry, we need to do more. As a company, we're working to do more. I think one example of something that we're leaning into ties back to this point on talent development and recruitment, and how do we create opportunities in underserved parts. One of our factories is in Chicago. How do we create opportunities for trade schools in underserved parts of Chicago where motivated young professionals can have opportunities, and doing what we can to build awareness and support career development, but clearly a priority.
The next two questions are really around global strategy and adoption. And Nora asks, or states rather, disrupting supply chain is about more than AM technology. How do you implement a global strategy for distributed manufacturing within your customers' organizations? How do you do that?
Okay.
There are two different ways, and it's a great question. I think there's very different beliefs of folks that are here. At Fast Radius, we are building a globally distributed network of micro factories, each a carbon copy of our launch node in Chicago. as we talked about, is deemed by the World Economic Forum to be one of the most advanced factories in the world. And our strategy is to copy and paste that around the world so that our customers have confidence that the parts we make in Chicago will be the same that we make in Louisville or in Singapore or other nodes of production that have implemented this quality system. We believe it unlocks something we call the fourth modality of logistics, and that is through human history. We've moved parts three ways: by ground, by air, and by sea. Now we've got a fourth mode of transport, which is moving parts through the internet at the speed of light, producing parts proximate to where they're needed around the world. That is the distributed manufacturing vision that we're talking about here. But we think that requires consistency, repeatability in that distributed network in a way that we're just, the machines themselves are not there yet. Now, for prototyping, it's great. You can send it to anyone who has a machine and you can get a part that's generally close enough, and that's fine. But if we're talking about putting parts on planes or parts on cars or parts in a medical device, that requirement is different. And I think that's what you're getting at with your question, Nora, is for production, how does distributed manufacturing work? And I think we believe it is the requirement is we need to get better in the machines and reliability, repeatability in the machines, but you also need a quality system and a wrapper around those. As we look at the work that's actually done in additive, it depends on the technology, but maybe a third of it's actually done in the machine. A lot of it is done up front and or after the machine, or in the maintenance and calibration of that machine that is often different. And there's a lot of dials that can be turned, as we all know. And so I think it is that operating system for distributed manufacturing that really can allow this to scale at a production level. Now, there are many segments of the manufacturing economy where that's not going to be required, and that's good. But as we think about how do we get to that higher end of production and unlocking that in production, we think that is a barrier, is having a trusted global infrastructure that can be relied on. And so I think there's a place for multiple types of distributed manufacturing. I think at Fast Radius, we are leaning into the one that is focused on reliable, high quality production that can be certified to be used at real volumes and critical applications.
Yeah, I'll jump in to add. I agree with Luke. It starts with having a platform to facilitate both the management of the demand signals across your organization and effectively matching it with the supply, your machines either within your network or external to your network, and then having the mechanisms integrated into that same portal that can track and trace the work through to its completion. And so as you talk about us implementing with other customers, we tend at 3 Diligent to offer that as our kind of soup to nuts solution to our customers. But we did build our entire infrastructure. Our Valkyrie platform was designed with a bundle of microservices so that we could spool up instances for our customers as well, should they want or need to run their own distributed digital platform and not necessarily want to lean on us to be quarterbacking that for them so much as running it themselves.
Right.
If I could just maybe add a different perspective, and I think it's very similar to what you're talking about. Anybody can buy machines, right? Anybody can plug them into any factory around the world and have a distributed network. The differentiator, though, are processes or knowledge. It's things we've been talking about. I think Lou hit on it. You've got to be able to have the same processes that are on the West Coast as the East Coast, as they are in India, as they are in other parts of Asia. And that's the challenge. And those technologies that are out there, anybody can buy software packages. But really it comes down to, I think, a lot of management discipline and the ability to be able to do cookie cutter processes so that you have the same kind of knowledge when you walk to one factory to the next. It's like going to a Safeway or an Albertsons, right? You know where the product is on the shelf. But it doesn't matter if it's in Arizona or if it's in New York. And it's similar when you're, doing the same kind of distributed network, across the globe. You've got to be able to have the processes, the repeatability to be able to get the most benefit out of your equipment.
Yep. Yeah. A machine and a material doesn't give you a reliable output, guys. Wherever in the world it is, you just can't assume just because it's the same machine model, you're going to get the same output. Even if it's running the same material, there's a whole lot of process and other controls that go into reliable production parts in a truly distributed way.
So a lot of it, you talk about strategy then, right? There's a lot of training that has to be able to go on. So
Sure.
From maybe the corporate office, right, to be able to put the standards out, to be able to roll out these kinds of processes. And companies are doing that today. And we've experienced it, with our own products that we're making, this distributed network. And it's challenging, but it's very doable. And it's kind of the wave of the future because we want to be as close to the manufacturing process as we can.
Just to piggyback on that, Mike, I think that's the exciting thing. It is doable. Now it's a question of how do we keep doing it? How do we do it at scale, which is what we're all working towards. And a great community here trying to advance that together.
You're right. It is fun.
And then how do we have products that justify its need, right? Continue to help building the business case. It all comes back to the business case, and people need to understand if it can't always be cost, it's going to be performance, or it's going to be flexibility, and making sure that that messaging can successfully land at the CXO level, so people will make the strategic investments they need to, because they don't want to disrupt their supply chain. They don't want to have to do it. There has to be a compelling reason, and we have to provide it to them.
We're almost out of time, but I hesitate here whether we have about a minute left, but I'm going to dive into this last question because I think it's going to be a good one to end with. How do you think the U.S. supply chain network is embracing additive manufacturing versus how other areas in the world are embracing it? So how are we doing as a country versus other countries around the world that have adopted AM at some level? This was directed to me and well, to Mike and myself, but I think any one of us can dive into this. So
Colin, you actually look like you have something you want to say there.
Well, yeah, the nice thing about 3 Diligent is we've got the full range of additive technologies, and we do have manufacturing facilities on 6 continents. So we've got I would like to think, a good perspective on this question. And I would love to hear the HP perspective too, but I would say that America's a little behind Europe, to be blunt, and I'd say we're a little behind Asia too. I think that in Europe, particularly Germany, they've been an absolute leader in the space in terms of innovation and driving technology. With the entry of companies like HP and Carbon and Desktop Metal, there's been a great kind of American push, I would say, recently. But in terms of broad-based adoption, we are still not the highest cost country. I think we keep on coming back to cost. I think some of the really high cost countries have been forced to be on the leading edges of additive. So I would say some adoption there. And then in the case of Asia, they've said, oh crap, we can't afford to lose this. So I think they've embraced it really robustly. America, I think, has a little catching up to do here, but it's not everywhere the way it is in certain parts of the world. That's my 2 cents.
Mike?
So at HP, we've done a lot of work with our network within all of our customers that are providing printed product. And through this COVID crisis, without that network of people to be able to work with each other, to be able to, because again, we've got this flexible capital, we're able to print and meet orders across the United States. Lou can be doing it in Chicago. We can have folks on the West Coast, and we even have people in Canada that are all working to be able to deliver product. So we do have a distributed network that's working really well within our little world of multi-jet fusion within Hewlett-Packard. And then you tie it out to our customers and our printing partners that are in Europe. So now we've got this extended ability to be able to get closer to that distributed manufacturing network we were talking about. But I think the U.S., from our perspective, is doing pretty well there from our 3D vantage point.
Lou?
I think if I could add to that, perhaps with a perspective broader than 3D printing, but on Industry 4.0 technologies broadly, of which 3D printing is one component. I think the research shows that we are woefully underinvesting and way behind what's happening elsewhere in the world, and it's a real problem. Mm-hmm. So I think there are pockets of bright light, and Mike has highlighted some of them, Colin has. But I think as we think about competitiveness on a global scale for Industry 4.0 leadership and innovation, we've got a lot of work to do. And there's an opportunity for us. We innovation in industry is in the DNA of our country, and I carry a great deal of optimism about what will happen here over the course of the next decade. But we should be very aware that both Europe and Asia are investing well ahead of what's happening here.
Yeah, it's an interesting question. I think it requires probably another hour of conversation because I think it's almost dangerous to generalize that. It depends on industrial sector and the type of activities, the research that's being done. I mean, Someone once said that our university system is the envy of the world. And I still think that is true. I really do believe that. Now, are they all working at the level they need to be in additive manufacturing? Probably not. There's a lot more that needs to be done there for sure. Not only at at the higher ed levels, but across the board. And so with that, I'm still, well, and then of course we have America Makes, and so we that is something that we hold up a big signs, and others in other countries have tried to mimic or do something similar, and so that says something that, hey, we are doing some things right. So with that, time has more than expired, but that doesn't mean this is the end of the program. We have about another hour left of networking. If you didn't join us during the first 25 minutes or so, it's a great opportunity to do some one-on-one or one-on, I guess, tables of 6, and it's a great format, and I urge everyone to stick around to join in on specific topics at various tables and lounges. So I'd like to thank our panelists, Colin, Lou, and Mike. Thank you very, very much for your time. You spent more time than just today. We had some preparation leading up to this, so thanks for it. And so with that, I'd like to turn it back over to our host, Link3D. Thank you, Link3D, for hosting this, and to America Makes for making this happen. Thank you very much.
Thank you.
Thank you.
Thank you to everyone. We will now be going into virtual networking. If you have any questions, feel free to chat me or come find me at the tables. Thank you, everyone. Enjoy.